So understood this orthogonal matrix concept? Okay. So I will take one example. E to the power ta minus 3 2 0. Sorry. Matrix A is given minus 3 2 0 0 minus 3 1 0 0 minus 3 minus 3 2 0 0 minus 3 1 0 0 minus 3 is the matrix. I am asking to find out E to the power ta. This type of questions will be coming in the second quiz. If you look at the matrix, eigenvalues are what? How much? What are the eigenvalues of this matrix? Lambda is? Am I correct? All minus 3. Lambda is all minus 3. That means if you have one eigenvector and two generalized eigenvector, can you tell me what are the eigenvectors and generalized eigenvectors? Eigenvector and generalized eigenvector. First I am asking for eigenvectors. First I am asking for eigenvector. What is the first eigenvector equation? A minus lambda I. Lambda is same all the place. What is that? 0 2 0 U1 1 U2 1 U3 1 0 0 0. Am I correct? Yes or no? Okay. Now it is your part. You should tell me the answer. Now it is your part. U3 1 3. Remember that last equation is having 0 into U1, 0 into U2 plus 0 into U3 equal to 0. That means U1, U2, U3 could be anything. So last equation cannot be put as data. This equation you can see U21 equals to 0. That means U21 equal to 0. And U21 equal to, and then 2U1 equals to 0. So 2 of U2 equals to 0. That means U2 is confirmed. So then what will actually happen? What's your final answer? 1 0 0 is the right answer. 1 0 0 is the right answer. Okay, next eigenvector. A minus lambda I U2 equals to U1. This is generalized eigenvector. A minus lambda I U2 equals to U1. What is U2? What is U2? What is U2? A minus lambda U2 equals to U1. What is U2? What is U2? U2 is second or generalized eigenvector. Second vector or generalized eigenvector. Please do the row echelon form. Row echelon form will have the same 0 2 0 0 0 1 0 0 0 and right hand side will be what? Will be 1 0 0, right? Yeah. So answer is 1 half and 0. You are very correct. Now you understood what is generalized eigenvector. A minus lambda I U3 equals to U2. Second generalized eigenvector. Please tell me. Second generalized eigenvector. Second generalized eigenvector. Quick. How much? All half. Yes, you are very correct. Half, half, half. Done it. Half, half, half. Okay. So now, what will be your J matrix? inverse AP equals to J. Can you verify J is having, what should be your J? Without doing the calculation, you can tell that minus 3, 1, 0, 0, minus 3, 1, 0, 0, minus 3. Are you getting it? Right? That will be your J, right? P inverse AP equals to J. So that's your J. Are you getting it? Jordan canonical block. Are you getting it? What's the P vector? The P vector is three eigenvectors. One eigenvector is 1, 0, 0. Next is 1, half, 0. Next is half, half, half. What is P inverse? Who will give me P inverse? I am just doing one more practice for you. Remember that the exam you have to verify. You cannot just like that do that, because exam you have to verify for your safety to make sure that your eigenvectors are correct. If it is not correct, you won't get proper Jordan canonical matrix or Jordan block. You won't get proper Jordan canonical matrix. So can you tell us what is P inverse? Can you please tell us what is P inverse? Can you please tell us what is P inverse? I am expecting the answer for P inverse. I am expecting the answer for P inverse. Once you are done with P inverse, so you can have P inverse AP. Yes, sir. 1. I'll go vertically. 1, 0, 0. Minus 2. 2, 0. 1, minus 2. Is it acceptable? Okay. Now, how to calculate P inverse AP? I'll give the technique. What's the technique? P inverse AP. P inverse AP. What's the technique? Okay. P inverse you got already. 1 minus 2, 1. 0, 2 minus 2. 0, 0, 2. AP means what will happen? A into eigenvector. A into this eigenvector. A into this eigenvector. So you can directly get the answer. What do you get the first column? What do you get the first column? A U1 equals to lambda U1. What is U1? U1 is 1, 0, 0. So lambda is how much? Minus 3. So what did you get for first column? Minus 3, 0, 0. Second column will be AU2 is what? AU2 is U1 plus lambda U2. Am I correct? How much is the second column? What is that? Minus 3. Am I correct? Last column? Minus 3 by 2. Last step. So this is the way, this is the new technique we have learned today. So P inverse AP is not that difficult. P inverse, if you just do work hard, do P inverse, AP can be directly obtained without doing the multiplication. And then if you multiply, you get the Jordan block. What's the Jordan block? the Jordan block. Once you are done with, we will directly go and get the solution. For the first approach, what we have done, then we will discuss the second approach to use the fundamental matrix. I want you to make sure that you are getting it. Are you getting it? I am getting answer only for two people. So you can see that if you multiply, you are getting -3 already. Okay? If you multiply this one, what you are getting -3 minus plus 3 by 2, 3, so it will be 0 only. No. -3
plus 3 plus 0.
I think something must have gone wrong here. Are you getting it? It should be having -3, 1, 0, 0, -3, 1, 0, 0, -3. Is it 0? That's what my question is. Check it out. Is it 0? Sure. Is it verified now? I want to see that at least one person should tell me that Jordan block is obtained. You got it? Huh? Which one?
A12.
This should be
-2.
AP matrix, what is -2?
A1.
This one is how much? This one.
No, the 1, 2.
-3, -2. Please tell me the position.
A1.
A1, 2. -3 by 2, -2. Then this one is? That's what I was asking 1,000 times. Please tell me, don't tell me the wrong answer. Now it is correct. When you, who got it there? Somebody told you got it. Did you do this way? Then why you are telling me wrong answer? Don't try to act smart because he is saying -2. I am not depending on you. Did you do AP like this? You directly got, you have done a fast step. That means, if I give you the easy step, you give wrong result to me. Then what is the use of to have easy step? Krishna, what was the mistake? It was always the mistake. Is it correct now? Don't say if you, I have the formula. Why should I say if? If should not be coming. What is my AU2? AU2 is nothing but U1 plus lambda U2. Where is the problem? There is no question of if. AU3 is what? U2 plus lambda U3. That's what I am asking for. And here what is actually happening? Everything. So this A, if I have the first vector, it will be lambda into U1. A into second vector will be U1 plus lambda U2. A into third vector will be what I wrote? U2 plus lambda U3. That's all. Only addition of two vectors. Just calculate, recalculate and check it. Yes, Ravi Teja. So please don't keep wrong because I am giving you the easiest thing. I am telling you like this. I have not taught in last year. I am doing so much for you. I am not doing anything from you out of that. Are you getting the final result? Is it correct now? Krishna, ready? Did you check? I don't know because I am doing so much. I am not getting much from you guys. I don't know what to expect out of me because I don't know. I am doing everything. What's a Jyoti? You cannot even say anything. At least they are interacting. What's happening with you? You don't know how to do matrix multiplication? Then what's the problem? results you have given to me. Please verify A, P is correctly. I have given such a simple thing. Now the thing is that you want me to do it. A is what? A matrix, it is A into P. You are, I don't know what you are actually expecting out of me. -3, 0, 0. Next is, I will bring the column by column. Second column is U1 plus lambda U2. U1 is what? 1, 0, 0. Lambda is -3. U2 is 1 half 0. So you are getting 1 -3 -3 by 2 0 -2 -3 by 2 0 is correct. See, why you have not done this way? Why you are giving wrong result? Don't try to give fast. See how much time you spend now. We have lost so much of time because of I assume this much that we correctly did it. And then now third one is what? U2 plus lambda U3. Am I correct? Correct. So U2 is what? 1 half 0 plus -3, which is half. So it is 1 -3 by 2. Is what is how much coming? Minus half. Half -3 by 2. Please see how dangerous things you have given this comment. We just how dangerous we have done the mistake. You guys think you just like that do that? This much steps I am showing. I am telling last year I have not done even 10% what I am doing now. And last step is what? -3 by 2 is correct. So this is the right answer. So you wanted me to do the solution. That is a level and a shortcut technique. No textbook will discuss this way exclusively. And I am not getting any answer from you. You want me to do everything. I don't know what to expect. In Jyoti, I am really upset with you. Nothing I am getting. What do you expect out of me? Yes. Now P inverse AP is coming correctly. See the level. I have spent 15 minutes for some silly point. I don't know what I am teaching this class. So it is -3 1 0 0 -3 1 and 0 0 -3, right? P inverse AP. Okay. Now what actually happens to the 3 by 3 system? You know that this J matrix can be further decomposed. J matrix will be further decomposed to J1 plus J2. J1 is -3 0 0 -3 0 0 0 -3. J2 is 0 0 1 sorry 0 1 0 0 0 1 and 0 0 0. Am I correct? And this we have seen earlier, they commute. So e to the power jt is nothing but e to the power -3t 0 0 0 to the power -3t 0 0 0 to the power -3t e to the power j2t. What's the final answer? E to the power j2t how much? I think you have already done it. E to the power j2t you already have your answer. Your answer booklet. E to the power jt is nothing but e to the power -3t 0 0 0 e to the power -3t 0 0 -3t, and we have already in our answer booklet, which is 1t t square by 2 0 1t and 0 0 1. Is there, right? Already. And final answer, you already have an answer booklet. So I have the final answer now. E to the power jt, final answer is, what is that? E to the power -3t, e -3t, t square by 2 to the power -3t, 0 e to the power -3t, e to the power -3t, 0 0 e to the power -3. What is now e to the power t? P e to the power jt p inverse. P to the power jt p inverse. P to the power jt p inverse. Final answer. P e to the power jt p inverse. P to the power jt p inverse. the power JT P inverse. P matrix is there, P inverse is there. You have to just multiply P into the power JT P inverse. Have you done it? Got it? Have you got it? Any answer from your side? Any answer from your side? Power PA. Got it? Nothing is there in the board. Just P inverse you already have. What is P inverse you got? Where the P inverse? It is 0 to minus 4, 0 to 2. Check it out. P inverse is 0 to minus 4, 0 to 2. Minus 4. Okay. Fine. Now we can easily get it. First, okay, tell me first row wise. First column or row wise, whatever. First entry, e to the power minus 3b. Second row, second column. First 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 row, second column. Takes so much of time to do matrix multiplication. I'm surprised. What did you do with the what? Huh? 2t. Next. We are telling one, nobody else is telling anything. D square. Next. Second row, first column. 0. Next. Minus 3. Next. Next. You keep it for yourself. It is what T. This is the technique we have done already. This is a known technique. Now we are going to introduce something what we have learned using the fundamental matrix, where if the power T, we have seen that MT into M inverse 0. Now how to construct MT? MT means each of the column of the M matrix will be the independent solution of the final solution vector. Okay? So now, as we said initially, we are now obtaining e to the power Ta via fundamental matrix by a fundamental matrix M. And what is M? In M, each column is the independent solution. Now, we got, this is the eigenvector, the generalized eigenvector, the generalized eigenvector, the eigenvalue is only 1 lambda, which is -3, right? This only we have. Since these two are generalized eigenvector, they cannot form the basis. They cannot form the basis. They cannot form the basis of the solution. Okay? They cannot form the basis of the solution. So, find solution. Using eigenvector, where x bar, which is I am writing as gamma 1, x1 e to the power lambda t plus gamma 2, sorry, u1 should be u3 plus u2t plus u1 e to the power lambda. As we discussed, as we said that in our previous example, this is the original eigenvector. This is the d square by. Okay, this is original eigenvector, this is generalized eigenvector, this is the generalized eigenvector, and that is the final solution. Okay, that is the final solution. That is the final solution. Okay. So now, how to validate? This will satisfy dx is equals to x. Okay. So what will happen if you want to validate? You know that why I wrote e to the power lambda t and all, because if eigenvector decomposition, we know summation of alpha I t uy. This will not work here. Okay? Alpha I t is nothing but alpha I t to the power lambda t. And I am telling this as a constant gamma 1, which has got alpha 1 0. Gamma 1, gamma, we will write all those alpha 1 alpha 2. That's why I wrote. So this is coming from here. Since they are not the eigenvector, so they are not forming the basis. Rather, I can write in this fashion. Why I can write? Because of the generalized eigenvector definition. Now we have to validate whether our assumption is correct. Question is this correct? Why it is correct? Dx dt equals to gamma 1 u1 lambda e to the power lambda t gamma 2 u2 plus u1t e to the power lambda t plus gamma 2 u3 plus u2t plus u1 t square by 2 e to the power lambda. What I did, this is like ddx of ub. First I took this guy as a v. This I took as constant and this I took as derivative. So if I take derivative, what actually happens? This guy will go now. There is no time dependency. It is u2 only, and this is 2 into half into 2t. Okay, so it is like u1 into t. Okay, so this part is okay. And when I next term of the derivative means this will be taken constant and this will be taken derivative. That's why this I think we have lambda here, right? Okay, this part is clear. So this is equation number A. Equation number B will be Ax, which is A into whole solution, which is gamma 1 u1 e to the power lambda t plus gamma 2 u3 plus u2t plus u1 t square by 2 e to the power lambda t. Equation number B. Right? Compare equation A and B. Same thing I discussed previously. if you compare equation B, equating the constant term, what actually happens? Compare equating the constant term. So constant term means I can equate with the u1, u2 and u3, right? Both sides. I can equate the u1, u2 and u3 both sides. What actually happens? So if you equating constant term, we have gamma 1 u1 lambda plus gamma 2 u2 plus gamma 2 u3 lambda equals to a gamma 1 u1 plus a gamma 2 u3 lambda. Sorry, u3 bar. Are you getting it? Check it out. If you don't get, please ask me. Are you getting it? See, there are coefficients of t square by 2 and constant term. What I did, I took only constant term. There are coefficients of t. Coefficient of t can be equated. Coefficient of t square by 2 can be equated. So dx equals to a constant equals to constant. Coefficient of t will be equals to coefficient of t. Coefficient of t square by 2 equals to coefficient of t square by 2. I am now equating constant term. Is the funda clear now? Are you getting it? Yes or no? Yes. Next step will be what? Gamma 2 u2 equals to gamma 1 a minus lambda I u1 plus gamma 2 a minus lambda I u3. Are you getting it? From here, gamma 2 u2 you are just taking it here, and gamma 1 a u1 already there minus lambda u1 you are getting, and gamma 2 you are having a u3 and you are having from here lambda u3. Finally, what you get? What is a minus lambda u1? What is that? Okay, excellent. What is this a minus lambda u3? u2, you are right. What you got? Gamma u2. Gamma u2. That means our generalized eigenvector definition is benchmark. Because of generalized eigenvector definition, this solution is the valid solution. Otherwise not. So same thing. Equate the terms involving the t coefficient. If you want, I can do that, but if you do, it's better now. Otherwise, I will be learning once again. You won't be learning. Equating the terms involving t. Equating term involving t. What you get? Equating term involving t. Are you getting the benchmark? So if you equate the term involving t, you get gamma 2 u1 equals to gamma 2 u1. Similarly, equating term involving t square, you will get gamma 2 a minus lambda I u1 equals to 0, which is original eigenvector definition. So please go back home and do that, because I cannot do all the steps. In that case, I cannot cover the things. I have done the difficult step. These are all easy steps. So what you got that? You got all the steps correctly. So finally you found that this is the solution. So now one thing is very clear. You don't care how many generalized eigenvectors are there. 4, 5, 6. This is the solution. Okay? It could happen that you have, I take an example. For example, you have eigenvector lambda, 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 say lambda 4. Okay? What will be the expression of solution? You tell me. Gamma 1 u1 lambda t. Next is
u1 t square
you are just telling something nonsense, then don't tell something. Gamma 2, yes. That's what Jyoti's thing is. Something she wants to tell. Gamma 2. What is that? You want U4 because lambda 4. This is distinct eigenvalue, boss. That means this thing and this thing are independent. This original eigenvector and this original eigenvector are independent. They are not. So please tell me the proper answer. Gamma 2 into. If these two are independent, what will be the solution? You see, these are not there. What will be the solution? If lambda 4 there, nothing else is there. What is the solution? Don't tell U2. Please tell gamma 1. I am just requesting you. If you talk like this, you won't learn mathematics. Already you are not learning. Please talk in terms of gamma 1. If these two are not there, what is the solution? Only 2 by 2 system. What you can write? If I have a 2 by 2 system, what should I write solution? Distinct eigenvalue. Gamma 1, U1, lambda t then plus, we are saying gamma 4 because of this, U4. Now I am adding this. What will happen? See the level. This is called kindergarten way of teaching the postgraduate mathematics. Maybe Monisha can learn because you have to go and teach. This is the way. You are a mathematician, you have to teach a postgraduate mathematics in a kindergarten level of teaching. Tell me the answer. Now I am adding 2 like 2. What is the solution? Plus gamma 2, U3 plus U2t plus U1 t square by 2 e to the power lambda. That's you can put here gamma 3 for your convenience. This much you cannot tell. Boss, these things nobody taught me. I told you that when I learned, I was a TA for a class. And during TA hours, I have learned by myself. My boss will not teach me. That's why maybe I am learning so much. I am telling you that best way of learning that you learn by yourself. If I teach you, it is guaranteed that you will learn it. Because something you won't get by hard learning, you won't appreciate. Understood that part, right? Now the final step. I will take only 5 more minutes. Okay, so your solution is, now you got the solution. What is the solution? Gamma 1, first eigenvector is 1, 0, 0, e to the power minus 3, am I correct? Second eigenvector, second solution, gamma 2, what is U3? Half, plus, U2 is what? What is that? T by 2. You cannot even talk properly because you don't feel the mathematics. That's a problem. Then next is t square by 2, 0, 0, e to the power minus 3t. And nobody could tell me the answer. Are you agree with this? So simple, nobody could tell me the answer. Okay. So what you can write? This you can write gamma 1, 0, 0, e to the power minus 3t. Plus gamma 2, you can say half, e to the power minus 3t, plus you can write gamma 2. Remember that we need to have 3 columns, independent columns. Otherwise you cannot have fundamental matrix. So far you have only 2 columns. You cannot have fundamental matrix. Fundamental matrix is square matrix. So you need to have 3 columns such that all these 3 columns are independent and they form the basis of the solution vector. Okay. So gamma 2 is, what is the gamma 2? Rest of the terms? Who will volunteer? Gamma 2, rest of the terms. I need to have the 3 columns. Remember that. As such, we have only 2 columns. So what we can do? We can extract this term and we can add this to and make the third column. What is that? What is my third column? T plus t square by 2. T by 2. Okay? So we can actually have this one as C1 100 e to the power minus 3t, C2, and modifying further C2, you can have your own modification. e to the power minus 3t plus c3 t square by 2 t by 2 1 by 2 e to the power minus 3t, where c1 equals to alpha plus half alpha, sorry, gamma 1 half gamma 2, c2 is gamma 2 and c3 is gamma 2. So I am just collecting further the terms to get much more simplified way. So C1 is gamma, C1 you can see gamma plus of gamma 2, and C2 is gamma 2 and C3 is gamma 2. Okay, so I am getting this 1 0 0, t half 0 and t square by 2, t by 2 1 by 2. Are you getting it? Yes or no? Got it? Sure. Sure. Check it once again. Check it once again. Are you getting it? Ravi Teja. Yes. What's the fundamental matrix? Remember that fundamental matrix may not be unique. Ravi Teja may get one fundamental matrix, you may get different fundamental matrix, but MT into M inverse 0 should be the same. But MT and M inverse 0 should be the same. What's the final form? What's the final form? Final form is 1 0 0, t half 0 and t square by 2, t by 2 1 by 2. That's a fundamental, that's the final matrix. A matrix is t, sorry, what is that? 1 0 0, t half 0, t square by 2, t by 2 1 by 2, right? Of course e to the power term should be there, which is e to the power minus 3t right? So e to the power minus 3t 0 0, e to the power minus t to minus 3t half to minus 3t 0, t square by 2 minus 3t, t by 2 minus 3t half t to the power minus 3t. This is mt. We can get m0, right? Which is 0, sorry, 1 0 0 0 half 0 0 0 half. Remember that with diagonal matrix. It cannot be a null matrix, a problem. That will actually give the benchmark of what is that. So then your e to the power ta will be mt, m inverse 0. And next class you should tell me the answer. So my question is, I am asking you whether you are getting the final answer of e to the power. Your final answer is coming that way or not. So it is e to the power minus 3t, t to the minus 3t, half to the minus 3t, t square by 2 to minus 3t, t by 2 minus 3t, and half to the minus 3t. M0 is 1 0 0, 0 half 0, 0 0 half. What is M inverse 0? Let's see who can tell me quickly. 1 0 0, 0 2 0 0 0 2. If the party can really obtain. If you give me 1 minute, I can show you here itself. MT M inverse 0. Can you multiply and give me the answer? Then only one step ahead, one step only for getting the final solution, and we can then discuss. MT M inverse 0. MT is there, M inverse 0 is there. E to the power minus 3t, 2t to the minus 3t, t square minus 3t, right? Then 0 minus 3t, t to the power minus 3t, 0 0 e to the power minus 3t. So e to the power t you got here, and the same value, same e to the power t you got earlier. But here you can see that this method will work for n by n system. You don't have to verify whether J1, J2 commute and all. Without having J calculation, you calculate M fundamental matrix. You have M0, you have M inverse 0, and with that you got the answer. My point is again note down that whatever the fundamental matrix, This is unique. Thanks for your attention.